right? So pressure. What effect does pressure have on an equilibrium position? Let's write a little bit neater. Okay, pressure. Well, the two rules when we talk about pressure, we cannot really say whether it's going to favor a forward reaction or reverse reaction because we need to look at the number of moles in the reactions themselves. It's not as simple as the concentration agenda. So I'm going to give you a rule. I'm going to say an increase in pressure will favor the reaction producing the least number of moles. Okay, and then I'm going to do the reverse thereof and tell you that a decrease in pressure favors the reaction producing or forming the most or the highest number of moles. Okay, so let's talk about what do we mean by reaction producing least and greater number of moles, right? Let's talk about a hypothetical reaction in which I have A plus B and I've got everything in, and this is only relevant to gases. So we don't care if it's a liquid or aqueous solution. We only need to count the number of moles of the gases, right? Because this is the volumes. So 1A plus 2B gives me in a reversible reaction 2C, for example. Okay, so now you are aware that we have two reactions here. The one reaction is 1A plus 2B giving me 2C. Okay, look, I write this with a single arrow because this will be the forward reaction. Okay, then the other reaction is 2C gives me what arrow is that? 1A plus 2B. And as you know, this is the reverse reaction. Okay, this is the reaction going in the other direction. Now we need to ask ourselves, the following. Which reaction produces the greatest number of moles? So you add up the number of moles on each side. This one has 3 moles because this is a gas, so there's 3 moles over here, and this one has 2 moles over there. So clearly the forward reaction, Fr, produces 2 moles because it takes 2 volumes. So 1 volume of this plus 2 volumes of that is 3 volumes of different gases that it takes to produce 2 volumes of C. Then the reverse reaction produces 3 moles because 1 plus 2 gives me 3. Okay, now my question to you is, because pressure works inversely, right? An increase in pressure favors the reaction producing less moles because an increase in pressure decreases the volume, and volumes are what we are talking about when we discuss the number of moles. A decrease in pressure favors the reaction producing the greatest number of moles. So when I increase the pressure for this hypothetical reaction, I need to check which reaction is producing less moles. So an increase in pressure will favor the forward reaction for this specific one because the forward reaction produces less moles. And a decrease in pressure will favor the reverse reaction because the reverse reaction here produces more moles. So it clearly depends on what you are producing. Okay? In our hypothetical situation here, an increase in pressure favors the reaction producing 2, while a decrease in pressure favors the reaction producing 3. Okay, up the pressure favors the one making less moles. Decreasing the pressure favors the one making more moles. Okay, I hope that is clear. And there's the rule. Make sure you have it down, write it down. Let me give you one quickly and ask you what's the effect thereof. Again, let's take the ammonia one. N2 plus H2 gives me NH3. and this is going to be right, and everything's a gas in this equation. So how many moles are on this side? Well, it's going to be 1 plus 3 is going to give me 4, and how many moles on this side? It's going to give me 2. So the forward reaction produces 2 moles. Forward reaction produces 2 moles, and the reverse reaction, which goes in this direction, is the reverse reaction that produces 4 moles. Now if I ask you, and if I up the pressure for this specific example, okay, it will favor the forward reaction. Upping the pressure favors the forward reaction. Why? Because the forward reaction produces less moles. And how do you do this? You say, according to Le Chattelier, an increase in pressure will disturb the equilibrium position, and it will favor the reaction producing the least number of moles. In this particular case, the least number of moles is produced by the forward reaction. Therefore, an increase in pressure will produce more ammonia. It will be better for us to make more ammonia because you're going to be making ammonia quicker than what you can make nitrogen and hydrogen. What about decreasing the pressure? If I had to ask you what happens when I decrease the pressure, well, clearly you're going to say a decrease in pressure favors the reaction making more moles, and in this particular case it's going to favor the reverse reaction because the reverse reaction makes 4 moles. Okay. Right, please rewind, replay as many times as you need to do this. Okay, that was slightly different from our, or was it the same? Yeah, it's sort of the same case from a hypothetical situation. But remember, it's going to be different for each equation. Okay, and then finally, we're going to need to talk about temperature in the next video.